Hey all, welcome back. So in today's video we are going to discuss about the frequently asked questions in SystemVerilog. I have already made a video on this on Verilog, like Verilog frequently asked important questions. If you didn't see that video, I'll link that in the description box. You can go there and check it out. And in today's video we are going to discuss the same about SystemVerilog, like some of the most frequently asked questions in SystemVerilog. And along with this, if you also find any interview questions and if you are having any doubt on them, you can ping me. I'll definitely answer that. Okay, so let's get into today's video. So the first question is, why is system verilog important? System verilog is very important compared to that of verilog in verification environment. Basically, when you are developing the test bench for the RTL, mostly we'll be using system verilog and UVM in order to develop the test bench compared to that of Verilog. Why is this? Because many of you know that system Verilog is having many enhanced features compared to that of Verilog. Okay, it's having many enhanced features like oops and randomization, constraints, assertions, coverage. So all of these enhanced features in system Verilog make it more useful for developing the test bench compared to that of Verilog. And coming to like in there are many advantages, like in system Verilog everything is assertion based verification and coverage driven verification. Okay, so and also in system Verilog we have introduced the oops concepts, which makes we will be building the test bench on class based instead of module based. Classes is dynamic in nature, so because of the dynamicity we this can be the test bench that we are developing from one circuit, it can be reused for another thing also. So that is where all this features system Verilog makes it unique for verification test benches, okay, compared to that of Verilog, right? So this is about why is system Verilog important. So next, the second question is, what is the difference between module and class based test bench? This we have discussed now only. So basically, modules is nothing but when we are writing something with module based. For example, if you see the Verilog, in the entire Verilog code, you will be developing both the test bench as well as your RTL also on module based. Okay, but when it comes to system Verilog, since it is having the enhancer feature called oops concept, so that is why we will be building the test benches using class based test bench. Okay, so now let us see what is the difference between module based and class based test bench. Basically, module instances that we are creating, those are created at the compile time. That means they will be existing from zero until the that means zero time unit to the simulation ends. So until when you are writing anything between module, your simulation will be starting from zero, and until the simulation ends you can't make any changes within that module. Okay, we cannot change the behavior of that particular module in case of either test bench or else in case of RTL also. So which is why, since we can't make any changes in that particular module, so that means it can't be reused, is it or not? Okay, so but in case of classes that is not the case. Classes are dynamic in nature. We can call that module instances are static in nature. Static means they can't be changed whatsoever. They can't be changed. Since they can't be changed, they can't be reused. That means there is no more flexibility. But when coming to class instances are created and deleted during simulation time, which is why we can reuse them. Okay, so we can create them and we can also delete them during the simulation time, because of which by we can configure the test bench architecture, and also we can reuse the class instances, because of which there is more flexibility by using the class based test bench compared to that of module based test bench. Okay, so this is the difference between module and class. Simply speaking, modules are static in nature, so that is why they can't be reused and there is of less flexible. Okay, but coming to classes, they are dynamic in nature. Dynamic in nature means we can easily create them and delete them. So that means that they are more flexible compared to that of module instances. Okay, so that is the difference between class and module. Hope you got an idea on it. Now coming to the third question, which is what is the difference between dynamic and associative array. I have already made a video on differences between all these arrays in single shot. I'll link that in the description box. You can go there and check it out. Here we will be explaining only the difference between dynamic and associative array, but there are further arrays like fixed size array, dynamic array, associative array, and queues. Okay, you have to know the difference between all these four things, because the questions can appear in any way. Like here it is asked that the difference between dynamic array and associative array. Similarly, they will be asking questions on difference between associative array and queues, difference between static array and dynamic array. So in this way you should know all the difference between all these four arrays. Okay, so I have made a separate playlist on arrays in SystemVerilog. Arrays in SystemVerilog is most frequently asked concept. Okay, so that is why I will link that playlist also in the description box. If you want, you can go there and check it out. Or if you are already familiar with arrays but you just want to have a recap on all these arrays, I'll link that particular video where I have discussed all the differences between all the arrays. Okay, you can just go there and check it out. Now coming to what is the difference between dynamic and associative array. So in dynamic array we need to allocate the memory before using it, right? But we don't need to allocate it as soon as we are declaring the array, but we need to allocate it. But when before we are using, we need to allocate it. In case of fixed array, as soon as we are declaring it, we need to allocate the memory. But in case of dynamic array, it is somewhat leisure. That means we can declare the array at any point of time, and when we are using that particular array we need to allocate the memory for it in case of dynamic array. But in case of associate before using it, but in case of associative array it is not like that. We can allocate the memory only when we are using it. Okay, that means when we want to assign some value into my array, then I can automatically create my memory and I can assign it immediately. But in case of array, dynamic array, that is not the case. When we are okay, I want to assign some value into my array, then before assigning that value only I need to create the memory and then I have to assign it. But in case of associative array, you can do both things at the same time. You can just allocate the memory and you can just throw the value into that particular array. Okay, so that is the main difference. Here in dynamic array you need to allocate the memory before using it, but in associative array you can allocate the memory when you are using it. Okay, and then the second important thing is, here in case of dynamic array you will be using only particular data types, like you can use only integer data types, or in case of dynamic array. Okay, but in case of associative array that is not the case. Here in case of associative array you can use any kind of data types, like mostly we'll be using the string data types. When you want to use the string data type for your array, then you will be using this associative array. Not only string data type, you can use any kind of data type in case of associative array, but in case of dynamic array this is limited. Basically we will say that in dynamic array we will be using only integer data types, but you want to use any string data type or any class structures, then you will be going for associative array. So that is the difference between dynamic array and associative array. Okay, and there are many differences, like how we are going to declare it, how we are going to assign the value. So all these things, as I told you, I have clearly explained all the things in that particular video. You can just go there and check it out. But when you are attending any interview, you can just give these two things as your answer. Those are enough, right? So this is the thing. Now the fourth question is, what is polymorphism? Here we here this is just a definition. When you are asked in an interview, you can just tell the definition. But when you want to know the in-depth knowledge on what is polymorphism, Okay, I have explained clearly. I'll also link that in the description box. And also, I have made a video on all the four important properties of whoops, like inheritance, polymorphism, encapsulation, and abstraction. So all these things, I have made a clear cut video on all these four properties in one shot with examples in my particular video. I link that in the description box. If you are interested, you can go there and check it out. But if you were asked in an interview like what is polymorphism, you can just tell it like that. Like it is the ability for the same code to act differently based on the object that you are using. That means basically, class means nothing but we can have different objects for a single class, is it or not? Right? So all these objects will be having the same code because they are coming from the same class. Okay, for example, what we can say is, if your class, for example, if you have a class named parent, okay, and if you are taking four objects for those parent p1, p2, p3, p4, then all these four objects will be having the same code. Code is nothing but same properties and methods which are belonging to the parent. Okay, so but based on the values, that means these four p1, p2, p3, p4 will be having same properties, but you can assign different values to that same properties. That means the same code acting differently. That is what the polymorphism means. Okay, here see, it allows the base class handles to invoke methods of its child class which have the same name. Okay, that means it by using the parent class handles you can invoke the child class properties also, right? So this is polymorphism. If you want a clear cut idea on this polymorphism, you can go to that video and check it out. But since we are discussing about interview questions, if you were asked in an interview, you can just say it like that, that it is the ability to have the same code act differently based on the type of objects that you are working with. Okay, clear? So that is polymorphism. Now what is the output of this following? Here many of you are still today asking me the about fork and join. Fork and join is also again very important concept, and it is also little bit confusing. How many times you are listening to that fork join concept, while you are listening you will think that yes, it is fine for me, but when you are estimating the output or when you are guessing the output of that particular code, then you may have the wrong answer in at some times. So basically this happens because of your lack of practice on this particular fork conjoin. There are some concepts in SystemVerilog like this fork conjoin which needs repeated practice on the codes, repeated estimation of the codes in order to have a clear cut idea on what is this particular fork conjoin process. Okay, so let's discuss now what is the output of this following code. If you see the code here, okay, you can see that this is only fork join. So you are having three types of fork join, which is flavors: fork join and fork join any and fork join none. Yes, so these are the three things. So based on the kind of flavor, like fork, if you are using fork join, then your simulator works in one way. If you are using fork join any, it will be working in another way. Like fork join none again acts in another way. So here as for now we are talking about fork join. Okay, so here I am having two begin and end, that means two processes. Okay, this is my process 1 and this is my process 2. Okay, many of you are asking me that here process means whatever you are writing within begin and end within the fork and join is considered as one process. So if you see here, all these processes will be starting at 0 time interval only. If you are having some 10 processes within your fork and join also, all the process will be starting at 0 time interval. Based on the delays that you are using and based on the inputs that you delays and values that you are using, they will be exiting out of that particular fork and join group. Okay, now if you see here, this is somewhat interesting compared to that of others, because here the delay is given but it is not given. Why? Because basically it is given as #0. #0 is equal to 0, is it? Is it really equal to 0? That is the question. Okay, if you know the answer, if you know the difference between has 0 and no delay, so tell me the difference between has 0 and no delay in your comment box. And if you really can tell the answer for this, I'm very happy for you. Okay, but if you don't know about the difference between has 0 and no delay, so let me explain this in this video. It is very interesting. So has 0 and no delay are same actually. So but they are different. In what way they are different is that whether you are giving no delay or has delay, that is considered as same. Okay, but during the time of execution, because in Verilog, as I told you, in Verilog or SystemVerilog also, you will be having regions. Okay, in Verilog you will be having 4 regions where the execution takes place. Is it or not? So they are active, inactive, NBA and postponed, right? So this is in case of Verilog. In case of SystemVerilog, you are having other things. Okay, like these again are subdivided into 12 regions. We'll be discussing that further. So as for now, okay, as for Verilog only we will be going, since we didn't explain about these 12 regions. So as for now, we will just talk about the 4 regions which are active, inactive, NBA and postponed. Okay, if you see the active and inactive, basically what is the difference between active region and inactive region is that if there is no delay, then that particular statement will be executed in active region. And if there is delay, okay, like hash 0, okay, if there is delay like hash 1, hash 2, it will be executed based on the particular time units in the either NB or postponed regions. But if this is hash 0 is nothing but no delay in the sense. You are giving something. Why? Because if you want some of the statements to be executed in an active region, okay, that means if you don't want them to execute in active region, in the same way you don't want to give any delay word. As soon as all the active region statements are executed, then immediately if you want that particular statement to be executed, then in such cases you will be using this hash 0. Hash 0 is nothing but all the statements that are given with hash 0 are executed in the inactive region. That means if there are any no delay statements, those will be executed first and then it prefers for hash 0. Okay, so that is the difference between hash 0 and no delay. Basically all the no delay statements will be executed first and then comes the opportunity for the hash 0 statements, then the hash 0 statements will be executed in inactive region. Okay, we have talked this about in case of Verilog regions also. You can go there and check it out, right? So here one more interesting thing here is, here in the first statement 2 hash zeros are given and in the second display B 1 hash 0 is given. That means here it has to wait for 2 hash 0 times and it has to wait for 1 hash 0 time. That means here the first display B will be executed and it will be B statement will be displayed first and then the A statement will be displayed. Why? Because the B is given for only 1 hash 0. So as soon as all the active statements or as soon as all the no delay statements will be executed, then immediately it will go for B and then it will go for A. Okay, got my point? So this is about how this is going to work. Now my question for all of you is, try the same thing for join any and join none also. Okay, try the same code for join any and join none and try to estimate the output and ping me in the comment box so that I can understand whether you have understood this particular topic or not, right? So this is the how the thing happens. Now what is the output of this following code? Okay, you can just pause this video and try to estimate it and give me the output in the comment box. Okay, tell me the output of this particular thing in the comment box. Okay, so try to estimate it. Here everything is same. Okay, since we have already discussed this already, I think you will definitely give the answer. If you understood this particular topic, then you are definitely going to answer this without any wrong thing or without any doubt, right? So this is the thing I want the answer. Try to estimate the answer for this particular code. Right now, the last question is write rand constraint on a 3-bit variable. Okay, you will be asked constraints in this way. You will be given the condition and you will be asked to write the constraints. Okay, constraints is very important in SystemVerilog. Without constraints, you don't get, at least you will not pass out the inter SystemVerilog test. Okay, you can expect at least one question from this particular constraints topic, and also the questions will be in this way only. You should write the code is nothing but you should write the logic, that's it. Okay, when are you going to write the logic? When you know how to write the logic, then you can write the logic. If you don't know how to write the logic, then how are you going to write the logic and how are you going to write the constraint for that? So that is why, okay, I'll link all the constraints videos in this particular video. You can go there and check it out. I have explained all the constraints as detailed as possible in my videos. If you see that video and if you are still having any doubts on the constraints, you can ping me in the comment box. Okay, so here what is the thing that was asked? Write rand constraint on a 3-bit variable, okay, with distribution 60% for 0 to 5 and 40% for 6 to 7. So if you see here, that is the 3-bit variable. So 3-bit variable means it will be from obviously 2 down to 0. So 3-bit variable means nothing but you will have 8 combinations. That means 0 to 7. So in this 0 to 7 I am putting the limitation. What is the limitation? From 0 to 5 it should come for 60%. The distribution should be for 60%, and from 6 and 7 the distribution should be of 40%. Okay, so for this you need to know what is constraint distribution. Okay, constraint distribution is nothing but the weightage of that particular constraint. So what is the meaning of this particular question is that when you are randomizing this particular bit, for example, if you see here the bit is value, when you are randomizing the value, then at least 60% of the time, that means out of 100% of the time, at least 60% of the time you should have the variables between 0 to 5 only. Okay, and the further remaining 40% of time you should have the variables like 6 and 7. That means 0 to 5 should come more frequently compared to that of 6 and 7. Okay, so that is a 6 and 4. For this you have to write the constraint. So how are you going to write this constraint? Constraint name, okay, and this particular constraint, what is this? Value. Okay, for this particular variable, okay, I am writing the constraint. So dist is the keyword for distribution. Okay, dist means how many times, weightage of that particular variable. So what is the weightage? Dist is from 0 to 5 it will be for colon equal to 60%, that means 60 times, and 6 and 7 variables. Either you can write it 6 down to 7 or you can just write the concatenation operator within this like 6 comma 7. In this way also you can write. Okay, 6 down to 7 it should come for 40 number of times, semicolon end. So in this way you should be distributing that particular variable in this manner. Okay, so in this way you are having many more other things, like you can use implication operators, and you will be asked to write a implication or use the implication operator, or you will be asked for soft constraints. Okay, or else you will be asked like you can use the inside constraint in order to write the code in this way, or you can write the conditions based on you can write the constraint with the conditional operators or if else blocks. In this way you were asked questions on the constraints. Okay, so for constraints you need to know what is the logic, like how to write the constraint on that particular variable. Okay, So this is the thing about constraints. So these are some of the most frequently asked questions. So as for now, these are the questions. In the next video, we'll be discussing furthermore questions. And also, if you are having any other questions related to SystemVerilog, you can ping me. I'll try to include that also in the next videos. Okay, so that is all for today. If you are new to this channel, consider subscribing this channel and hit on the notification bell also. Also, please share it to all your VLSI enthusiastic friends who also want to enter into design and verification domain within VLSI. That is all today. Thank you.